All I know is they shut the record. At first, I'm in Canada. And I'm like 4 years old. Most people
Yeah, it's a long story. Now I'm at the point I get a good haircut. Looks like Bowie Bridge is hanging down, upside down. Yeah, right. Bad weeks and stop sniffing glue. Yeah, I got it. Yeah, I got a really bad haircut. You got a bad one. Chronic in my hair. Yeah. Go Riders. Go Riders. Yeah, it was a great game.
was that correct? No, what sort of it?
Yeah, great game. Yeah.
Does ATSC 3.0 ever get out?
We want to change the
So
rules.
I'm hanging out with your buddy Andy Day.
Where's the pinhole screen? Spotlight for everyone? You see spotlight for everyone on that list? No. Do you see the title slide up there? Fucking That's why that doesn't have permission to.
So do me a favor.
I kind of like it this way. They get to watch me and I get to watch them. You know, so it kind of goes both ways. All right. Okay.
All right. Hello, everyone. We are ready. I apologize for some of the. Hey, quiet down. You. All right. Let's get this show on the road. Thanks, everyone, for joining us this evening. We have a little bit of some technical difficulties. So, is there an engineer? But welcome to our November STE meeting. We have a fantastic speaker and Matt from Shure. A little hand of applause for him. And if you guys, after our discussions, would like to check out the microphone up there. That's actually a microphone, that circular thing up there. Um, Please, head up there and check it out. A little bit of housekeeping. We have our Zoom going on, but we have a little bit challenge of some of the video. So it's going to be a little bit, just in-house kind of stuff. So again, thanks for everyone for being here and Thanksgiving November. So hope everyone has a fun one next week. As we traditionally do, we're going to do a pass the mic for anybody who has any announcements or discussions they want to start off on the meeting. Anybody at this table? Glennie?
Come on, Lenny.
I got nothing to say.
That is a first.
I just want to add to what Glenn said. We have nothing to say.
Joe. You want to add, Sig? Oh,
He had to say it, though.
So for those that know me, I like to brag a lot. Netflix just started a retail pop-up type of operation. They launched Netflix in Philadelphia, Netflix King of Prussia. It's a retail pop-up experience, and Diversified, it was my project, did all the specialty AV theater and digital signage and everything else in there. So I am bragging, and it launched November 10th.
How about their capsule power?
They've lost power twice and have had two different power surges. So it has been a challenge. I did not violate my NDA because that was the mall that had the power outage, not Netflix. But we are learning that certain devices on Dolby and AES 67 who need PTP clocks, they don't always grab the right master clock when they come up. And so, so if Joe doesn't show up to the next meeting or any others beyond, you might know what might have happened to him.
6 feet under.
That's great. All right. How about this table over here? Anybody have announcements, job openings, things happening?
We can neither confirm nor deny what Jeff said.
How about here? Howard, anybody? Doug, anything happening? Lloyd? Nope. Good. All right. Well, let's give another round of applause for Matt from Shure and the fantastic microphones we got going here.
Awesome. Thank you, Bobby. Thank you guys for having me here tonight. I'm really excited and honored to be in your presence and be invited out here to discuss something that I'm super passionate about, which is microphone design and wireless technology, what we're doing right now and what we have coming down the pipe in the future. So really cool stuff we're going to talk about tonight. If I can get my clicker to start working, that would be important. Uh-oh. This is starting off really hot. Oh, I have to press start. Aha, there we go. Okay, success. It's only downhill from here, right? So who am I? My name is Matt Forgey. I am the market development manager for Shure for the central and western US. So I get a nice big territory to manage. I've been at Shure for about 6 months, so I'm relatively new to the company. Previous to my time at Shure, I was chief audio engineer at a rental house here in town for about 10 years. Mixed a bunch of shows, flew PA, was an RF tech, system tech, all that fun stuff. So while I am relatively new to this company, so when I decided to make the jump over to working, it was a relatively a short putt, as they say, and a pretty smooth transition. We have a lot of smart people in this room. I don't pretend to be any smarter than anybody else in this room, that is for sure. No pun intended. But I have been, like I said, a heavy user of Shure products for a long time. I've been involved in some of the product development and beta testing for stuff we have coming out soon. So I hope to glean some information on you guys tonight, and hopefully you walk away with this with some new information and some fun facts and stuff about some of the cool stuff that we're working on and have coming down the pipeline. So why are we here? Everybody knows, everybody here works in broadcast. We have a ton of challenges today working in our industry when it comes to microphones and RF. So it is upon us as subject matter experts and industry leaders and as manufacturers to figure out what are we going to do about it, right? What are we doing to make our lives easier to ensure that we are being successful as broadcasters for the next 5, 10, 15 years through the changing landscape of different regulations and different, spectrum allocations and things that happen in those parts of the industry. So it's on us to reach out to you guys and figure out what your needs are and take that back to product development, take that back to the plant, and figure out how we're going to be successful going forward in this changing landscape. Before we're going to talk today about where we're at and where we are going forward, but I think it's important to take a little bit of time to look at where we've been, understand the context of where we've been in the past. It's exciting. It's an exciting. This is not a Shure microphone, I should say. Are we getting any better? This is better. And I think I'm being sabotaged so that I'm forced to donate a new kit next time I'm here. Okay, I'll be very gentle. I'll be very gentle. Like I said, only downhill from here, right? So it's a really exciting time to start working at this company because this year we are actually celebrating our 100th anniversary. So it's a really cool time. There's not a lot of companies in this business that can say they've been around for 100 years and are still growing strong, right? So yeah, let's give it up. I wish I could say I had something to do with the success of the company, but I just started literally 6 months ago. So I can't take much credit for it yet. But I want to run through a quick timeline of where we've been so we can get a better context of where we're going. Like I said, 100 years ago, 1925, Sidney Shure founded the company in Chicago, and we started making radio parts. Radios were all the rage back then. You had to buy them in kits most of the time. And so Sidney saw a hole in the market to start selling radios and parts. But if you're going to sell radios, you need content for those radios, right? And at the time, how did we capture content? With a microphone. So pretty quickly in 1932, we started making microphones. And there weren't a lot of microphone manufacturers in the States back then. Most of them were foreign. So that came in handy in the early 40s when World War II kicked off. And pretty quickly, we became the primary mic supplier for the US Army in World War II. And there was a lot of really cool innovation that came out of that time, right? We built these throat mics for the Air Force, and we built handheld push-to-talk mics for tank operators and headsets for all sorts of different applications. And so there was a lot of really cool innovation that came out of, obviously, a pretty traumatic time. But the one thing that was really important to Shure, specifically at this time, was this idea of building things to military specifications, right? Everything we had to build for the military was of mil spec. And that really landed hard with Sidney Shure and the team at Shure. They decided that going forward, they were going to build everything to this military specification. And to this day, that DNA has stuck with us in all of our product development, in all of our quality control. We still keep that mil spec in mind when we're designing and building new products. That's why our products are so durable. That's why they last so long. Everybody here's got an SM58 line in a corner, in a closet somewhere at home, in a drawer that's probably 30, 40 years old. That all goes back to this mil spec idea from back in the 40s. After the war, we started diversifying our products. We got into phono cartridges and parts for record players, all sorts of different electronics. So we really kind of started to blow up in a few different verticals. And then in 53, we had a breakthrough with, I don't want to say the first commercially available wireless microphone, but let's just say one of the very first commercially available wireless microphones in the Vagabond 88. This was a tube mic, so it doubled as a hand warmer, and it had about a 25-foot radius that you could operate in, so it wasn't very big. It also cost about $8,000 in today's money. So while it was a breakthrough in broadcast technology, it wasn't exactly the most practical product from selling to the general public idea. So, but still a pretty good breakthrough in the technology. They started developing that mic in the late 40s. We had a guy named Ben Bauer at the company who is one of the original, absolutely brilliant engineers at Shure, who was there in the beginning. This guy was decades ahead of his time as far as microphone design goes and wireless design. He wrote this memo to Shure's legal department in the late 40s. And what's really interesting about this memo is that he doesn't talk about whether they can build a wireless mic. He's talking about whether they should build it and what the government's involvement in that is going to look like. So all the way, 80, 90 years ago, he's worried about the FCC regulations surrounding our wireless transmission and what that's going to look like from Shure's standpoint, something that we're all very familiar with today, right? So we've been dealing with it from the very beginning of wireless mics. 65 was a banner year for the company. We released the SM57. What is there to say about that, right? Everybody's got one kicking around at home. This is the blueprint for all dynamic mics that we've made ever since then. Sold millions around the world. It's the industry standard. In the early 80s, we started getting into conferencing technology, and this was a whole new vertical for us. And obviously, for anybody who's involved in integration here, this has become a huge, huge market sort of on the side of pro audio, right? So not only were we focused in pro audio, but now we're focusing in the conferencing market as well, which has become a huge market for us as a company. In 2005, we had another banner year, another breakthrough product in the UHFR wireless. This was really our first professional analog wireless system that is still very much in use today. It was discontinued in 2017, but it's still very much in use today. And it's kind of the blueprint for all the wireless that we use today. Even our new digital wireless looks like our UHFR. It shares the same capsules, shares a lot of the same properties. And this was really a kind of a flagship breakthrough product for us 20 years ago. So that leads us to today. Where are we at today? In the last 12 months, we've released over 17 new products. What a time to start at the company, right? Thrown to the fire, as they say. Lots to learn. So there's a lot of new cool stuff that we're coming out with, and we're going to talk about some of that today. And in the future, we've got lots of cool stuff coming down the pipe. And so we'll see about that. What are our live production challenges today in 2025? Well, I think this kind of goes across the board for everybody who works in every department in broadcast. Do more with less, right? We have more expectations from production. Their shows are getting more complex than ever before, and you're expected to do it with less gear, less hands, less time, less money, all of that stuff. Bless you. So do more with less is a big challenge that we always face. As far as microphones go and microphone capsule design, we're always looking for better pattern control, better rejection, better frequency response, and better capture with less microphones. Again, more with less. We want to capture more of the environment and reject more of what's outside of that pickup pattern with less microphones. As far as wireless goes, it's all about spectral efficiency. We want to fit more channels and more devices with less RF space available to us today. Again, less is more, right? And then how do we control all of this? Well, we need to be able to control everything remotely over some kind of a network, whether it's you're doing audio transport via AES-67 or Dante, or you're doing some sort of proprietary protocol. Everything is remote controlled over a digital network. So how do we get around all those challenges and solve for those challenges? Well, in any manufacturer that you talk to today, not just Shure, there's a few common threads that sort of weave their way through product design. So these are themes and threads that are common to all manufacturers. They're not just the themes that you see in Shure products today. The interesting thing, and I think kind of the unique thing about Shure that I love, is that we are really a solutions-focused company. End-to-end, from microphone capture, all initial transducer, to the processing and remote control of that signal all of the way at the other end of the network. So we're going to look at audio capture. What are some new cool things that we're doing with transducers? Everything's going digital, so digital first for transmission and transport. We're going to look at what we're doing to solve for RF density and flexibility. And then how are we remote controlling everything, and what are our needs there so that we can get around those challenges with remote control. So the first thing I'm going to talk about is audio capture, microphones, right? Transducers. With traditional capsule design, our polar patterns are inconsistent across the frequency response, right? So your high frequencies are going to die off faster when you get off axis from that microphone than your low frequencies are going to. So that the pattern is inconsistent. Also, dynamic mics are very sensitive to structural excitation, so handling noise. So these are the two main issues that we have mostly with dynamic mics these days, and there's some ways that we get around it, but Shure is doing some really cool things to solve for these problems with dynamic mics. In current designs, we use a proprietary technology called a pneumatic shock mount to eliminate some of this handling noise. So there's two air chambers right back here behind the diaphragm that work like a piston to absorb any handling noise and keep the diaphragm from moving. We only want that diaphragm to move when a sound pressure level is hitting the front of the capsule, right? We don't want it to move due to handling noise. So it's effective, but it's very difficult to control. There's other ways that we can try to get around this, but all of these solutions take up a lot of space in the design of a mic. There's not a lot of real estate in the head of a microphone, right? So we don't have a lot of options, and historically we haven't had the technology and the software to design elements that will solve for these problems in the head of that capsule. Until now. Enter Shure's new line of Nexodyne dynamic microphones. So we have something called Revonic technology that we are building into this new line of dynamic mics. And essentially what it does is it incorporates two dynamic transducers, two entire microphone motors, precisely calibrated in the head of that microphone to work together for better polar pattern consistency, increased rejection, and reduced handling noise. So instead of having just one transducer in the head of that microphone, we now have two working together. So these two motors are structurally in phase. Essentially, they're strapped together, and they're strapped to the edge of that microphone design so that you can work them together and tune them together and give yourself a lot more room to work with as far as how these microphones pick up the sound. The second one, basically, we flip the phase on it. We put the second one out of phase, and then we're able to align it just right with the first one so that we create a much more controlled polar pattern hitting that first microphone. So much better frequency response across the entire polar pattern and much better handling noise that's being rejected from that mic, like it says right there. This is what the polar pattern looks like on our Nexodyne series of mics. Anytime you look at a polar pattern of really any other microphone, you're going to see that that polar pattern is very different from 1K down to about 250 hertz, right? You're going to get even if it's a cardioid mic, you're going to get a much more omnidirectional pickup pattern from those lower frequencies than you will from the higher ones. If you look at our patterns of the Nexodyne mics here, you'll see they're extremely consistent all the way across the frequency response from 250 hertz all the way up to 10K. Almost the exact same frequency response. This is pretty unprecedented in dynamic mic construction. With condenser mics, it's a little bit easier to do this because you actually have more components inside the head of that microphone to play with. But with dynamics, there's not a lot to work with, especially if there's only one transducer. So by having two whole transducers in the head of that microphone, we've got a lot more elements to play with so that we can tune this polar pattern to reject handling noise and get better off-axis response. So this is something that we're really excited about. It just came out this year. One of the great pieces of feedback that I get all the time is if I mic up a drum kit with this, and I've got a drummer that wears in-ear monitors. We get drummers coming to us all the time that say, I've never heard my drums sound this clear before. Because for the first time, they're actually just hearing the drum itself, and they're not hearing the resonance and the rattle and some hardware vibrating in the background that's just outside of the polar pattern. They're just hearing the drums and how clear they are. And they talk about how clear it is in their ears. So it's really exciting. It's something we're just getting off the ground right now, and we're excited to put it on more tours and get it out there and let people hear this new technology for dynamic mics. Okay, so that's dynamic mic design. Another thing that we're working on in audio capture is array and beamforming microphones. This is something that I've been spending personally a lot of time on. traditionally used in conferencing applications, and now for the first time being applied to the broadcast world. These array mics, these beamforming mics are nothing new. They've been around for a while, especially in conferencing applications, and they're not unique to Shure. Every company has come out with array mics that are being deployed in conference spaces and teaching rooms and things like that. You've got your ceiling mics, you've got a table mic, maybe you've got a bar at the front of the room. And so this array technology is not exactly new. But what is new is how it's now being applied in the broadcast world. And so for the first time, we at Shure have a product that is tailor-made, is a tailor-made array mic for broadcast. What is an array or a beamforming microphone? If anybody is unfamiliar, it's a microphone that uses a number of transducers in one piece of hardware in a specific pattern that are summed together. And then using DSP, you use the outputs of all of those transducers put together, and you're able to create a beam or a lobe that is very tight or very wide, depending on how you tune that beam. And how you program those transducers using your software determines how you can steer that beam or how tight or narrow that polar pattern is, that pickup pattern is. And what it gives you is just a really unprecedented amount of control over what you're picking up with that microphone and what you're rejecting with it as well. So people use kind of array and beamforming microphone like interchangeably. It's actually an array microphone with beamforming technology, with beamforming DSP that makes it possible. So how it works, like I just said, it's got a bunch of transducers arranged in a pattern. The sound signals that hit it from directly in front are going to sound crisp. They're all going to arrive at the right time, and they're going to be in that lobe, right? But any sound that is hitting those transducers from outside of that lobe or from an angle are going to have different time, is going to have a little bit of a different time and a different phase, right? And so using the DSP software, we can phase align those transducers, and we can cancel out anything that's outside of that lobe and really focus on the energy that's inside of it. So really great rejection and really great control and ability to pick up what we want to get exactly from that lobe. The shape of an array microphone really matters. We have both linear and planar array mics. So in a linear array mic, your transducers are all arranged in a line, right? So you really only have one axis that you can steer your lobes in. This might work great if you're above a table, right? And you're just trying to aim your beam at some chairs below, or if you have a front bar at the front of a room and you just need to arrange those lobes in one direction. A planar array gives you the ability to, has your transducers arranged in a two-dimensional pattern, so in an XY pattern. So that gives you the ability to tune them both vertically and horizontally across that plane. So we have a couple new products that are out that are planar arrays, but it gives you a lot more flexibility with how you tune those arrays. And we've got a DCA 901, which I've got here, and then the MXA 901 is our conferencing version that have this circular layout that gives us the ability to have a really, really tight polar pattern in that array. So like I said, we've been doing this for a long time. Remember that guy I talked about, Ben Bauer? Yeah, he was doing this all the way back in the 30s. 1938, he was doing all the math by hand to figure out how to make array microphones work. He was just ahead of his time, right? He was limited by the technology of his time, and unfortunately, he was not around long enough to see any of this actually get developed into a product. But when we started developing this in the early 2000s, we actually used all of his notes. We have his notes still in the archives back at headquarters in Chicago. And we used all of his notes and his development, his R&D in the development of these products, 60, 70 years later. So he was really, really ahead of his time and was really a brilliant engineer. Like I said, we first created these for conferencing. That's what everybody's done. But now, for the first time, we're bringing it into the broadcast space. 901 broadcast planar array microphone. So this is, DCA stands for Digital Capture Architecture. And this is this is our new system for capturing and controlling high quality digital audio via a network. In this case, Dante or AES 67. It has 8 steerable lobes built into it. So it is a full planar array microphone. You've got 8 lobes built into it that can be steered in any direction. So imagine it as 8 shotgun mics built into this one piece of hardware, right? And each one of those lobes can be steered and tuned independently from each other in any direction. It's got a whole bunch of DSP built into it with auto mixing, EQ, compression, delay, all this kind of stuff. So you can take those lobes individually over the Dante network, over those 8 channels, or you can submix them down into a built-in auto mixer and just take it over 1 or 2 channels. So 12 channels of Dante coming out of this one device, 1 cable, PoE, 10 watts, super efficient, and you essentially get 8 to 12 channels out of this one product. It's low profile. It also is, we're working on a lot of immersive capture stuff with this as well. So we have some 5.1 presets built in. So if you're trying to do some immersive capture, this is a great tool for that. And we have a lot more development in this to come as far as the immersive world goes. Why is this beneficial? Well, we've been talking about doing more with less, right? You get increased channel density with just one product, one endpoint, one cable. You get 8 individual microphones, right? So fewer endpoints to set and strike, less cable to run, and you get improved capture coverage and better rejection of your environment. Better control and management. It's fully remote controllable, right? You can adjust the mics remotely. If you're an A1 in a truck somewhere mixing a show, you don't have to call your A2 on comms to go out and move the microphone around if you've got an obnoxious fan that's getting picked up by your microphone. You got some guy out there talking crap and he's cussing and you want to keep him off air. You can digitally steer that lobe away from that fan, keep him off air, right? It's that easy. So you can adjust the mics remotely. You can capture only the area that's needed. It takes fewer people and fewer minutes to aim and to run. So there's a lot of capabilities there with having the remote control function. And then, of course, there's a bunch of DSP built in. So the auto mixing improves your workflow. It helps to isolate desired sounds and remove the unwanted noise. One thing that has been really cool to see is, sure, you can take in all those 8 individual lobes into your desk and mix them however you want, but you can also just take that auto mixer in on one fader as well and let the auto mixer do its magic, right? And so if you're like an A1 for basketball, they're used to just having one fader for each half of the court. I've got a shotgun mic on this side and a shotgun mic on this side. This allows them to keep that same workflow, but get much better control and coverage over the sound that's happening on the court. So they love it because it doesn't change their workflow, but they're getting much better audio quality out of it. Who's this for? I mentioned basketball. We purposely built this for sports broadcast, right? But as we all know, with any product, once it gets out there in the field, that genie's out of the bottle and you guys are going to run with it and try to use it for all sorts of crazy stuff. So I've been doing reality shows with it, putting it up in a house to use as a plant mic so producers can spy on talent even when they're not wearing a microphone. We've done a bunch of live events with this, so doing audience capture in 5.1 or multi-lobe configurations for live streaming, stuff like that. Audience capture for talk shows and game shows and stand-up comedy specials and all sorts of stuff like that. So a ton of capabilities and use cases for this outside just the world of sports broadcast. I mentioned it's remote controlled. So we've got this great web GUI for it. Up here on the right, you'll see these are the 8 individual lobes. And each one of these lobes, you can just click and drag wherever you want your coverage pattern to be. Really, really simple and fast to get up and running. There's also a great autofocus feature where if you're trying to pick up a specific person talking, you tell that lobe to listen and it will snap right to where that person is within about 2 seconds. So it's really, really fast and really great, convenient, easy way to tune all these lobes. On the left side, we have it's a full built-in mixer for this whole system. So we've got a channel strip for each individual lobe where you can route them all either direct out or sum them into the auto mixer. And then you've got full gain control and EQ and everything for each lobe. And then in the auto mixer itself, you've got noise reduction software built in, you've got compression, delay, all of that kind of stuff. So it is a full built-in mixer in the DSP to control this however you want for your show. Couple case studies here. I mentioned basketball. Basketball is probably the place where I've done the most testing on it. We've done a bunch of NBA games, a bunch of college games. And essentially what we do is just mount one under each stanchion in the armpit here, right? We fan out our lobes across the 3-point line, and then we'll do one at the free throw line and 2 underneath the basket. And now we have a really unprecedented amount of control over what we can actually pick up on the court. So as the guys are running around, chasing each other, dribbling the ball, each one of these lobes are actually turning on and off as soon as they detect a certain sound pressure level in that lobe, right? And the auto mixer is actually very smooth. So if we just have the auto mixer do its thing and send it to the A1, he doesn't have to do anything more than just pot up that side of the court, right? And the auto mixer does its thing. You're getting rejection of all the other lobes that aren't picking up any sound, and you're just getting the sound from whatever lobe is receiving, that right threshold. So really great coverage all the way out to about 34 feet from where the mic is back here to the 3-point line. We're looking at somewhere between 30 and 34 feet in a noisy NBA environment. You can't do that with one shotgun mic. I don't care how nice of a shotgun mic it is. With a shotgun mic, it's sort of a victim of its own circumstance. It's getting everything, right? It's not just getting the action on the court. It's getting all the ambient noise of the crowd and the room and everything else. So this product really gives you an unprecedented amount of control to be able to focus on the energy on the court and then, mix in your audience and your ambience in another way to your flavor. So that A1 has the control to be able to decide that himself. MLB is another place we've been doing a bunch of testing. We'll put one on each baseline, fan out the lobes between home plate and first or home plate and third. And now the director loves it because he can hear the pitcher on the pitcher's mound doing this with his feet in the dirt, playing with the ball in his glove. This center beam here will reach all the way to the pitcher's mound, no problem. And so generally traditionally we'll have a few shotguns out there. We'll have some back crack mics and a few parabs, but they don't get nearly that coverage that we get with an array mic like this. So the directors love it because now they're getting all sorts of crazy creative ideas on what they can do with that sound. And, we're having some really great success with this so far. Soccer is an interesting use case. Soccer is a big pitch, right? It's outside, it's noisy, it's windy, so it can be a tough environment. And traditionally, they're putting out about somewhere between 12 and 16 mics to cover an entire soccer field. We can get the same coverage with between 4 and 6 of our DCAs. So, and each one of those DCAs has 8 channels of audio on it, right? So a ton of coverage with just 4 cables, right? Rather than having to cable between 12 to 16 shotguns. So a lot less setup time and better coverage. One thing we're working on as well with this, as we do more software development and as this finally, gets out in the field, it's shipping next month, by the way, it's not even out yet. We're doing a lot of integration with third-party software. So with camera tracking software, with this edge sound research software, which uses tracking data to move cameras, and you can actually turn on and off the lobes based on tracking data or based on where the camera is looking rather than where it's detecting audio from. So a ton of really cool things coming down the pipe with this. I'm really excited to see where it is a year to 5 years from now. This is really the future of sports production and picking up nat sounds for games and stuff like that. So it's an exciting project to be a part of. Any questions on microphones, transducers, DCA? Yes, sir. Yep. My understanding is that it would be Oh, sure, yeah. Have we done any experimenting with mounting the camera on the microphone? Is that correct? The other way around, mounting the microphone on the camera. Yes. I don't know that we've taken one and put it on a hot shoe mount on the top of a camera or anything like that. But the testing we have done is just had it near the camera, right? And the great thing about it is because you can steer those lobes so well, the placement of it doesn't matter as much, right? What matters is just having it close enough and then getting that beam lined up to where the camera is looking at. So sure. it becomes digital inside the microphone itself. So we pick the sound up with the transducers, all the DSP is done inside, and then it's one Cat5 cable coming out of that that's already on the Dante network. Correct. So yeah, it's all Cat5. It's just Ethernet. So you get your power, your Ethernet, and your control, or your power, your control, and your audio all over that one cable. Yeah. Cool. Anybody else? Okay. Let's talk about something that I'm sure everybody in here knows and loves very much, the spectrum and RF. We're going to switch gears a little bit here. So this is our beloved spectrum in the US, right? And every one of these little boxes is a use case for RF, for radio waves in the US that is dictated and regulated by our beloved FCC. As we zoom in a little bit, this is all we get in broadcast. When we're using wireless microphones and wireless in-ears, this is all we get to work with out of all that spectrum. So if we look underneath that, zoom in a little bit more, we get a few bands to work with, right? We get a little bit of space in VHF. We get a little bit of space in ISM, STL up in the 900s. We've got some DECT and 2.4 and 5 gig that is useful, for comms and things like that, but not generally useful for mics in wireless live production. So really where we're operating and where we're talking about 9 times out of 10 is this UHF range right here, 470 to about 616. That's where the majority of all of our products lie. That's kind of the sweet spot for all of our RF technology. The spectrum's not getting any better, right? This is a few years ago. This is spectrum scans across the US. I think as we all know, as the FCC has been selling off spectrum, we've all had to repack down lower into the 470s and the 500s. And it's not just us having to do that, it's all the TV stations as well. So now not only do we have less space to work in, but we have more people than ever before to share it with. We have more wireless mic users, and we have more TV stations that we're battling with for space every day. So for instance, Phoenix, great place to use wireless, tons of open space, right? You get all these DTV stations in there, and we get 2 open channels of white spaces to work in. Really challenging space. This is actually a few years old. I can tell you it's gotten worse since then because I was just there 2 weeks ago. So we have a lot of challenges, especially in big cities with, shrinking spectrum and trying to fit more and more channels of wireless in that spectrum. So how do we solve for this? How do we fit more into less, do more with less? We go back to our core themes. I talked about digital first transmission and transport, right? So all of our products that are coming out now, not just us at Shure, but all products across the board, these themes I should mention are ubiquitous to all companies, right? That's called feedback. We just want to make sure you guys are awake tonight, right? I'm not boring anybody out there, are we? Okay, that was a test. What's that? Oh, right. Haha. Yes. Okay. Digital transmission. All the products that are coming out now are digital transmission, right? There's no more analog wireless. And the main reason for that is right here, little to no intermods, right? With digital transmission, it's much more linear. The amplifiers involved in it are much more linear. And so we don't have these intermods popping up with multiple transmitters that are taking up space in our spectrum that we now can't put another fresh frequency on, right? So on the left, we have 9 channels of analog, and you've got all this spectrum being taken up by the intermods of those transmit signals. With digital, you have the same 9 channels, and you get no intermods, right? So all that space is now freed up to use for fresh channels. Much more efficient, clean use of your RF space. So digital always. We're also trying to make our RF as dense as possible and as flexible as possible, right? We are now full wide tuning on all of our products. So no more narrow tuning bands to work with. No more block 24 electrosonics, right? No more G1 band Shure stuff. No more block 19. It's full wide tuning on all of our products. So for sure, we call it the G57 range, but it's the full 470 to 608 for all products. And we do that because we want to have the whole spectrum available to work with, right? As that spectrum is shrinking, We want to have any available little sliver of space that is open available to us to use for mics and in-ears. We also have the ability for the first time to transmit in multiple different carrier types on one product. So we have one product, and I have it here today, that will do digital narrowband, it will do standard and high density modes, it will do WMAS transmission. So we have, for the first time, you're not stuck to one carrier type on a product. You can transmit in multiple different carrier types with multiple different bandwidths on one product. So it's really up to you to use whichever of those transmission modes is up to you, is best for your use case. And then as far as density goes, we want to fit as many channels into every RU as we can, right? We're going to make our channel counts as dense as possible into every rack space. No more 8 channels with dual receivers that are in a 12 channel or a 12 RU rack that weighs 110 pounds, right? Just for 8 channels. We're doing super high dense channel count stuff now on both the transmit and the receive side. Speaking of WMAS, WMAS is kind of a buzzword, right? It's kind of been a hot topic in RF over the last year and a half. What is it? Well, it stands for Wireless Multi-Channel Audio System. And it's not a technology. It's essentially a regulation that has been released by the FCC about a year and a half ago. That's just dictating some parameters that we're now allowed to use. Traditionally, we were limited to, in both analog and digital, a 200 kilohertz wide carrier with one frequency, one channel of audio on it. Now with the new WMAS regulations, we're allowed to transmit multiple channels of audio on a carrier greater than 200 kilohertz, up to one entire 6 meg TV station wide. So you can do tons and tons of channels of audio in a carrier that's the size of an entire TV station. It's a technology neutral approach. Like I said, it's just a set of parameters, and all the manufacturers now are using these parameters to build their new technology into it and under. So it's kind of an exciting time to be involved in manufacturing and be involved in this technology, because this is such a big regulatory breakthrough. This is going to determine a lot in RF over the next 10 years, right? Everybody's going to come out with their version of WMAS. And I don't want to say it's a race to the finish, but it is a little bit of an arms race over, who's going to come out with the best product. So far, I think everybody's product has been really good. It's just what's the right tool for you, right? Everybody's products are reliable and sound great these days, but it's what is the right tool for the job for your use case. So WMAS is the future. We go from a narrowband carrier to our multi-channel wider carrier. And the first product from Shure that takes advantage of this WMAS regulation or parameters is our new Axion Digital PSM in-ear monitors. This is our first digital in-ear monitor. It's also our first WMAS product. If you're familiar with in-ears, you've probably used our PSM 1000. This has been our industry standard analog in-ear for over a decade. It's been on tours all over the world. It's still rock solid, but it's analog wireless, right? So it's got its own limitations involved there with the transmission side. But it has been a leader in the market and an industry standard. People have been clamoring for Axion Digital PSM. So took a little while, but it's here. Some of the key benefits of it is now wide tuning, right? Like we mentioned, one of our themes. The previous incarnation with PSM 1000 had narrower bands of tuning. This is now wide tuning fully from 470 all the way up to 608 in G57. So you can take the full advantage of the available spectrum. It's also a high density transmitter. You can transmit up to 16 channels of stereo audio in one RU. This one quad transmitter will do 16 channels of separate ears. It's also got analog and digital inputs on the I/O. So it'll do AES-3, it'll do AES-67, and it'll do Dante natively on the back of this unit, along with the analog XLR inputs that are on the back as well. So tons of flexibility with the I/O. It's low latency, it's got internal combining and all sorts of cool other features. If you want to do an ADPSM masterclass, come find me. It's only about 6 hours long. If you want to, use up a Saturday. I do them all the time. I think the coolest thing about this, and kind of the biggest breakthrough with this product that we've done, is this multiple modes of operation. So I mentioned multiple different carrier types from one unit, from one transmitter. This product will do analog FM transmission, which is your PSM 1000 technology. It will do digital narrowband, which is essentially your Axient digital mic technology in an in-ear monitor. And then it'll also do our 4-channel wideband WMAS mode, which the way that we're implementing WMAS is you get 4 stereo channels of audio in one 800 kilohertz carrier. So if you look at how these all line up against each other, you might say, you know, oh, it's 4 channels and they're each 200 kilohertz, just like this one. So what's the difference? Well, the main difference between the WMAS and our narrowband, even though it's still technically 200 kilohertz per channel, is that you don't have to worry about the spacing between the channels anymore. So with narrowband transmission, both analog and digital, we were historically calculating for 350 kilohertz spacing between narrowband carriers. So that's about 200 kilohertz for the carrier itself, and then 150 kilohertz for spacing between those channels. With that spacing calculation, in digital, you can get about 17 channels of audio in one 6 meg TV station. With analog, it's only 9. So with digital, you're getting almost twice as many channels of audio right off the bat. With WMAS technology, with our WMAS implementation, you don't have that same spacing requirement between the channels anymore. It's 800 kilohertz center frequency to center frequency between 2 channels. So now you can take those WMAS carriers, each with 4 channels of stereo audio, butt them right up against each other in the spectrum, and fit up to 7 of those carriers in one 6 meg TV station. That means 28 channels of stereo audio in one 6 meg TV station. Notice I said 28 channels of stereo, 56 channels of mono in one 6 meg TV station that you can now fit in there. What's great and makes this implementation of WMAS so flexible is it's super spectrally efficient. I don't have to take these carriers and put them all in the same 6 meg TV station. I can split them up across the spectrum and put them anywhere I want them to go within that 470 to 608 block of the UHF band. So if I've got little slivers of 800 kilohertz spacings open throughout my spectrum, I can take these blocks and spread them out however I want across the spectrum. But say you show up to a show site, you're at a festival or something, or a big broadcast facility, and you don't have any 800 kilohertz spaces available. You don't have any room for a WMAS carrier. The great thing about this product is we don't force you to use WMAS. You have that digital narrowband capability built into it as well, where you can do one channel on one frequency and it's only 200 kilohertz wide. And you can now slice and dice your channels all the way across the spectrum wherever you have an open sliver of space. So it really is the most flexible wireless product on the market today between those 3 different modes. You know, we give you the tools to kind of use it as you see fit in the way that is best for your application. I see a hand. Yes. You do not. This is all completely unlicensed. Yep. If you need a clean 6 meg TV station, well, first of all, you have to do a scan, right? And know if there's even a DTV station in that space. And then you have to coordinate for it, right? So if you're going into, say, Warner Brothers or something like that, you have to talk to the lot coordinator and go, hey, I see that this channel, this 6 meg channel is open from DTV. Are you guys using any space here? And so you do have to coordinate that with the lot. Now, if you need to use that entire 6 meg TV station, that's very tricky. It's hard to walk onto a busy lot and go, I need a whole 6 meg TV station. They might tell you to go pound sand, right? Or something worse. So that's what makes this product, I think, really important and really flexible, is the fact that you don't need the entire 6 meg TV station. You can slice and dice these carriers any way you want it, up and down the spectrum. Cool. Any other questions? Oh, yeah, I love it. Okay. No. Nope. Correct. Yep. So I can put this one down at like 472, and I can have this one at 505, and this one at 520, and this one at, 590 or whatever. You can put those carriers anywhere you want. The only restriction on where you put these carriers is it can't cross the border of one of those 6 meg TV stations. So I can't put it in between two, but I can put it right up to the edge of one or the other. Yes. Not Sure is always working on new and exciting things, I think is our tagline. I will say not at this time that I know of. Do you know of people in our space doing that? Okay. Let's sidebar. Let's talk afterwards. Wait, I'll buy you a drink. What's your drink of choice? Maybe, but not that I've been involved in testing just quite yet. Yeah. Okay. So that's WMAS implementation in ADPSM. We didn't really talk about like geographic coverage at all and what our needs are there. I could do a whole nother hour or two on RF over fiber and multi-zone antenna distribution and large deployments and all that kind of stuff. But one thing I will touch on real quick that only ADPSM does that's pretty cool is we have this idea of spatial diversity where you can take one channel on one frequency and split it out 2 different outputs, coded 2 different ways, and sent to 2 different antennas so that you can transmit and have multiple zones of coverage, or you can have extra robust coverage on your one zone. So traditionally, if you've ever tried to split an analog carrier, anytime those antennas overlap, you start getting dropouts and reflections and distortion and all sorts of stuff. The receiver gets confused. It doesn't know which antenna to pick off of, right? But with digital, we're able to code those 2 transmit signals differently and then decode them in the belt pack. So it actually works constructively instead of deconstructively. Yes. Yep. There's definitely timing involved. Yeah. You're talking about like the time difference in just that one channel or the audio that's actually coming into the unit? Yep. Yep. The belt pack does. When the belt pack receives those 2 signals, it can demodulate them and decode them and retime align them, I guess is my the wireless receiver, the belt pack receiver. Yeah. Yeah. Essentially it's a way to cover more area. So you can have 2 antennas on one stage. You can have one antenna or 2 antennas on 2 different stages or studios next to each other. So if you need to have talent be able to walk seamlessly from one stage to another without losing signal, it's a great solution for that. You can split these signals again to get diversity coverage in 2 different zones. And if you're doing an ultra big deployment, like a parade route or something like that, you can have your talent with their belt pack receiver walking through multiple zones of diversity along a parade route without ever losing signal or losing quality. So this is something that only ADPSM does. It's a really cool technology and just gives you a lot of control over your coverage. We talked about remote control, right? Everything is being remote controlled. We've had ShowLink remote control over our wireless microphones for some time. That is our 2.4 protocol for control and monitoring of our microphones remotely through this access point. But for the first time with ADPSM, we have remote control over the belt pack itself on stage while talent is wearing it. So now you can actually see and monitor what the talent is experiencing on stage for the first time. If they're getting dropouts, if they're experiencing signal loss in some way, you can see that visually on their belt pack remotely. So like I said, we've had this with mics for some time. It's not new, but what is new is having it in an in-ear for the first time. If they unplug their headphones, it'll tell you. If they turn their volume all the way down and think that they can't hear anymore, the pack will tell you. Other than that, it gives you battery life, it gives you RF level, it gives you audio level, all that stuff. So as a monitor mixer or an RF engineer, it's really an unprecedented level of monitoring and control to see what your talent is experiencing out on stage in real time. Cool. So Axion Digital PSM kind of checks all the boxes, right? It's got all the digital transmission and I/O that we talked about. It's super dense and flexible, and it's remote monitored and via Workbench and ShowLink and all that kind of stuff. So it really checks all the boxes for what we need to solve today's RF problems. Okay, we talked about ears. What about microphones? I swear this is the last product. What about microphones? Well, we need a highly dense, highly scalable, highly flexible wireless mic receiver, right? And so the newest receiver that we're coming out with, or we came out with this year, and I have one here, is the ANX4. This is our ultimate wide tuning, scalable, high tier, high density wireless receiver. Everybody's coming out with multi-channel, highly dense receivers and transmitters these days, right? Once again, this is not, just a Shure thing. This is kind of an industry-wide theme. Everybody wants to fit as many channels as possible into whatever their rack space is, right? So this is Shure's answer with the ANX4. It can do up to 16 channels of Axion Digital or 24 channels of ULXD in one rack space. So once again, gone are the days of having a rack this tall just to do 8 channels of wireless, right? This is 16 or 24 channels in one RU. This is a global wideband solution. So it will receive every ULXD transmitter and every Axion Digital transmitter that we make worldwide. It'll receive from 174 megs all the way up to 2 gigs. I don't know about anybody else, but that's the widest tuning range I've ever seen in a receiver. So if you're on a world tour, you can take your rig with you, and you just have to worry about whatever band the transmitters are in from country to country. So as you go from Korea to Japan to Germany, and they have different spectrum rules and different transmitters that they have to work with, this is one receiver to rule them all that will receive all of those different transmitters. If you run a Fortune 500 company with installations all over the globe, this is a great tool to be able to manage that. It's just one SKU for all of your receives. It does do 96K Dante or AES67. It is a digital first and a digital only product. So we're looking at Dante or AES67 only for your audio output. It's the same trusted RF quality and audio quality that you're used to with Axion Digital and ULXD. So it's essentially the same experience as you're used to with both of those products, but just in a very dense, very flexible space. What kind of problems does this solve? Well, obviously it's one RU. So weight, size, power, cost are all better with the ANX4. Like I mentioned, it's wideband, so it works everywhere. It's one SKU to rule them all. And when you break it down and you look at cost and everything, you get about a 25% savings on cost and an 80% savings on weight and rack space versus your traditional dual and quad receivers. So a ton of benefits here with this single RU system. Yes. Yeah. Yeah. Well, that's a great question. They're only, like the FCC, for instance, is only worried about the transmit side. They're not worried about the receive side, right? So the only way that you can tune it to something that's illegal is if you have a transmitter that's illegal that you got from another country, right? So you have our transmitters are still limited to the US rules, right? So I can't have a transmitter that transmits at 800. Sure. Mm-hmm. Yep. That is correct. Oh, sure. So if we have a receiver that receives those frequencies that are technically illegal in the US, how do they prevent people from using those channels, right? We can't prevent them from using it if they have the transmitter. There's really nothing that we can do other than have regulators and have frequency police and coordinators out and about to regulate that. And I can guarantee you there will be a lot of out-of-country freaks that come here. I can also tell you that in talking to a lot of large production companies and rental houses around town, they are in a lot of talks with the FCC over expanding what we're allowed to use for that time. So they can, do temporary licenses and things like that to go into other bands so that they're able to use channels that we aren't typically allowed to use. So in theory, if they have those transmitters, if they brought them over from Korea illegally, this would still receive it. There's nothing we can do. We're not making a transmitter that is 174 to 2 gig. We're only making the receive side of it. Does that answer your question? Okay, cool. Any other questions? No? Okay, this is our first license-based product. So you buy the box, you buy the ANX4, it comes empty, and then you buy a channel license for every channel of receive that you need to go on this box. It's not a subscription. I see some groans out there. It's not a subscription. It will never time out. It will never expire 5 minutes before you're going to go live on a show. And once you put that license on the box, it lives there in perpetuity. It never has to touch the internet again or anything like that. So it is a permanent license, and it is managed via our Shure cloud platform, which I'm going to talk to in a second. So I know there is some hesitation and groans around licensing and things like that. In talking with our end users and our customers, the real advantage of doing it that way is that that's the best scalable way for a customer to get into this ecosystem. So they buy the box, and then they only need to buy the amount of channels that they need. So if they need 4 channels, their price is reduced, right? They only get 4 channels. And you can add as many channels as you want over time to be able to scale up your system and kind of stretch out, your inventory, stretch out your investment to eventually max out your system at either 16 channels of Axient or 24 channels of ULXD. Correct. So the license itself is agnostic between ULXD or Axient Digital. Same price, same license. And to your point, a lot of people who are current ULXD users are actually excited about having the opportunity to now have somewhat of an upgrade path to Axient Digital. They can stretch that out. Previously, you'd have to make a pretty heavy investment if you wanted to upgrade your 24 channels of ULXD to Axient Digital all at once, right? Now you can just buy the receive side, use it in ULXD mode until you're ready to make a new investment into transmitters. You then make that investment into Axient transmitters, flip this to Axient mode, and you're good to go. You're fully upgraded, and you've been able to kind of stretch that out over a period of time and make that transition a little bit easier. So there are, again, those licenses also as well are transferable. So if you run a rental house and you've got multiple ANX4s, say around the country, you can take those licenses off the ANX4 and through the Shure Cloud platform, move them from one box to another. So if you need 8 channels here and 8 channels here, and tomorrow you need 12 and 4, those licenses are infinitely transferable. You can move them from one box to another as many times as you want. So it provides you a lot of flexibility in where you deploy your channels without having to move the hardware. I was talking to a guy doing college integrations the other day, and he's got a bunch of Axient in his football stadium, and he's got some in the theater on campus. And the football stadium only gets used from September to December, right? Or September to January. And then the theater is getting used the entire rest of the year. The gear in the football stadium stays there. He would love to be able to redeploy that gear to the theater or elsewhere on campus in the off season without ripping out that hardware. So this gives him an opportunity to leave the hardware in the football stadium, take the licenses off, and redeploy them on hardware elsewhere in his venue. And now he's got all those channels that he's able to use in other venues without ripping out the hardware. So in certain instances like that, there is a lot of flexibility here with how you manage your inventory and how you deploy your channels. Excuse me. Like I mentioned, it is managed through our new Shure Cloud platform. So if you do integrations or you're involved in IT at all, having everything cloud managed and remotely controllable via the cloud is the direction that everything's going, right? Especially in IT or AV, you want to be able to manage large inventories of things over the internet in the cloud. Traditionally, this is something that was really just for our conferencing products. We've been doing this for a while in that market. And now, for the first time, we're starting to see our pro products being integrated into the cloud as well. This is really being driven by that IT world, where conferencing and pro audio are really starting to kind of blur the lines. And I'm sure a lot of you guys have seen this, where conferencing and broadcast and pro are really kind of like becoming blurred, right? There's a lot of conferencing applications where they want to do a live stream, which is essentially becoming a full-blown broadcast, right? Or there's broadcast facilities that also have conference rooms and teaching spaces that want to be able to tie into other venues on that campus. So those lines are to be able to manage their Axient Digital or their ULXD in the cloud along with the rest of their conferencing products. This is not something that I ever used before I started working at Shure. This is something that I was unfamiliar with, but now that I've seen it in action, I really see the benefits of it. If you've got a bunch of receivers that are all on the cloud at all times, you can remote monitor everything. You can push software licenses or software updates, firmware updates remotely. And if somebody's having a problem with something, you don't have to necessarily go down to the facility to see what's going on. You can pull it up remotely and monitor it remotely from the cloud and see what's going on there. So a lot of our pro products in the future will start to be integrated into this Shure Cloud platform. There's a lot of benefits there, and it's going to be the future of remote control and monitoring for our products. Okay, that's pretty much it. We covered all 4 of the themes. I talked about audio capture. We talked about everything going digital. We talked about everything being as dense and flexible as possible, and everything being remote controlled via Workbench and the cloud. So thank you guys for having me. I think my time is just about up. Here's to another 100 years. We're going to continue to be solutions focused on the entire ecosystem, focus on the end user, because at the end of the day, it's not just about me trying to sell you products. It's about you being successful on your show, right? It's really not about the microphone that you're buying. It's about me selling you a tool to be successful. So that's what we're going to continue to focus on. And yeah, thank you guys for having me.
All right. Any questions we have for Matt? Anybody? Right. All right. Well, our next meeting is December the 18th. Look for announcements coming out on locations and things like that. We have a couple of things that are in the pipeline. Then January, we have both talk about wrist in February. January, we'll have Rydell in as well. So thank you everyone for coming tonight and have a good time.